Assume that we have a polynomial of form an xn plus an minus 1 xn minus 1 plus dot 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 a1 x plus a0. Then for such a polynomial we can find a rational root r is equals to p over q such that p is a factor of constant term a0 and q is a factor of leading term coefficient an. It's possible that this polynomial has no roots, but the rational root theorem is saying that if a root exists, then that root must follow this rule that the numerator must be a factor of constant term, whereas the denominator is factor of the leading term coefficient. Let's do an example to make this crystal clear. In this example, we are given a polynomial x cubed minus 3x square minus 4x plus 12, and we are asked to find all the roots of such a polynomial. If we are able to find one root, then for the remaining polynomial we can easily apply quadratic formula and find rest of the roots. So we will find one root using rational root theorem and we find other roots using quadratic formula. Let's do that. According to the rational root theorem, a root r of the form p over q such that p is a factor of 12 and q is a factor of 1. Luckily, 1 has only one factor, which is 1. So that means our denominator will be 1. Now we have to find possible values of p. For that, we have to list all the factors. So p could be plus minus 1 because plus minus 1 divides 12. P could be plus minus 2 because plus minus 2 divides 12. P could be plus minus 3 because plus and minus 3 divides 12. P could be plus minus 4 and P could be plus minus 6. And finally, P could be plus minus 12. So in total, 1, 2, 3, 4, 5, 6 times 2, 12 possibilities for P. We have to try all of these possibilities and then we will be able to find one root. Let's try 1 and minus 1 first. So 1 is equals to 1 cube minus 3 1 square minus 4 times 1 plus 12. This is equals to 1 minus 3 minus 4 plus 12. And that is in no way is going to be equals to 0. 1 is not the root of this polynomial. Now let's try minus 1. Minus 1 cube minus 3 times minus 1 square minus 4 times minus 1 plus 12. This will be equal to minus 1 minus 3 plus 4 plus 12. And this also is not equal to 0. Now let's try our luck with 2. With 2, I will have 2 raised to power 3 minus 3 times 2 raised to power 2 minus 4 times 2 plus 12. And that will be equal to 8. 3 times 4 is 12 minus 8 plus 12. And here these two cancel with each other and these two cancel with each other. So my answer is 0. That means I am able to find a root of this polynomial which is equal to 2. So I have found a root using rational root theorem and my root is 2. Now I'm going to use this root to find rest of the roots. By using factor theorem that we have discussed a few videos ago, I can say that a polynomial x minus 2 divides p of x. Therefore, I can find rest of the polynomial that doesn't have this root by dividing p of x with this. X cubed minus 3x squared minus 4x plus 12 divided by x minus 2. I have to multiply it by x squared. It will be x cubed minus 2x squared minus plus, these terms will cancel. I will get here minus x squared minus 4x plus 12. Now to get minus x squared, I will multiply x by minus x. I will get minus x squared plus 2x plus minus, these two will cancel with each other. I will get minus 6x plus 12. Now to get minus 6x, I multiply x by minus 6. I will get minus 6x plus 12. So my remainder is 0. This confirms that 2 is indeed a root of this polynomial. And my quotient is this polynomial. That means I can write p of x as x minus 2 and multiplied by this quotient, which is x squared minus x minus 6. I have already found one root of p of x, which is 2 from here. To find other two roots, I have to find factors of this polynomial. So now let's factorize this quotient polynomial. X squared minus x minus 6 is equal to x squared minus 3x plus 2x minus 6, and that is equal to, I take x common, I will get here x minus 3, I take plus 2 common, I will get x minus 3. So my other two factors are x plus 2 and x minus 3. Let me clearly write my answer. So we have found that this polynomial has 3 factors and 3 roots, which are as follows. Its 3 factors are x minus 2, x plus 2 and x minus 3. Its 3 roots are, from this we get a root of 2, from this we get a root of minus 2, and from this we get a root of plus 3. And I have found these roots using factor theorem. So it has these 3 roots.